Lesson 2 today, point slope form. And so our objective 1, will be sorry for the typo. We will be able to write and graph linear equations in point slope form, and we'll be able to analyze different forms of a line to interpret the slope and y-intercept of a line of a linear model in the context of data. So we're going to use point slope form sometimes just as a launching pad to get to other forms of an equation. So we can do lots of things with an equation once we have the numbers inserted into the formula. So we know the slope formula. As I've told you guys, that's going to be part of your math lives from now on. You'll use it in algebra, you'll use it in geometry, you'll use it in pre-calc, you'll use it in calculus. This is just a basic algebraic formula that gets used all the time. So you need to have that one committed to memory and be able to think about it. That needs to just come to mind. Like if you're talking about a problem, you need to find slope. You don't need to have to think about that one every time. You just need to remember it. Slope-intercept formula is the most basic form of a linear equation that we use, and also with that one, you guys need to have that just seared into your memory banks because you'll use it all the time in other classes, in future math classes. So today we're going to add to that one that's you may not use as often, but it's really handy to know, and it is it makes life easy because we could do this with just slope-intercept formula. Bennett.
Can I just give you the equation I got first and then?
Just a second, just a second, and I'll call on you for that. So we could write an equation in slope-intercept form using the information that we have here, but we'd have to manipulate the equation to find the y-intercept, and we'd have to take some steps. Or we can just insert it into a new formula, and the equation's already written for us. So, Bennett, go ahead.
Okay, so I got y minus 2 equals to 1 half parentheses x minus 3.
X minus 3. No problem with that at all. We're going to leave the y as part of our formula, the x is part of our formula, as we're used to having. Slope-intercept has a y and an x in it, right? And so we're used to having those letters as part of our formula. We know what the slope is because we're told the slope, that's 1/2, so it goes in for m, and then the y1 and x1 just are taken from our ordered pair that we're given. So that's perfect. And once we have it in this form, then we can do stuff with it. I could put this now into slope-intercept form if I wanted to, right? All I've got to do is get y by itself. I've got to distribute here, add 2 to both sides, and then I would have it in slope-intercept form. So we could do y minus 2 equals 1/2 x minus 3/2. All I did was distribute, right? And then we can add 2 to both sides. So that would be y equals 1/2 x plus 1/2. We're good. That's slope-intercept form now. We have y equals mx plus b. Slope is 1/2. That doesn't change. We knew that from up here. And now we know that the y-intercept is 1/2. Okay? I mean, there you go. That's it. So write the equation of the line in point slope form that passes through the given point with the given slope. So, what do we got? Calling for number 5 here.
Y minus 5 equals negative 3 parentheses x minus 1 close parentheses.
Guys, that's it. That's point slope form. Bennett, yeah, it's Bennett. Tell me number 6.
Y minus 3 equals to 2 parentheses x plus 4.
Good. Plus 4 because it's a negative. So minus a negative, we would do plus. That seems pretty simple. All right. Seems like you guys are on board with that. Now, uh-oh, write the equation in point slope form for the line that passes through these 2 points. So what do I need to do first?
Slope.
Gotta find the slope first. So I know the formula for slope. Slope is y2 minus y1, 3 minus 4, or sorry, 3 minus 1 over
2.
Two plus 4.
2 plus 4, 2 minus negative 4. So that would be
2 over 6.
2, why did I put 4? I have 4 on the brain, so 3 minus 1 is 2. 2 plus 4 is 6, so that is 1/3. That's my slope. Now,
I guess like substitute the y and
so which one do I use?
I'm using the second one.
Yeah, I'm
Because
using
it's got
two.
negative, so it's
Yeah.
easier.
Would it be wrong to use the other one?
No.
Nope, you could use either point. It doesn't matter which one you use, you can use either one.
Just depends on what you
So-
do for-
Y minus
Y minus 3.
3 equals 1/3.
Third. Parentheses x minus 2.
Okay, or
Y.
minus
What?
1.
minus 1 equals
1/3 parentheses x plus 4.
x plus 4, okay? It's kind of weird to think about because usually when we're doing slope-intercept formula or slope-intercept form of an equation, how many ways is there to write a slope-intercept equation for a line? There's one way to write a slope-intercept equation for a line, right? It's gonna have the same y-intercept and the same slope. So you can't write that any other way unless you monkey around with like the fractions. If it's 1/3, you leave it as 2/6, or you leave it as 3/9 or something like that, but it's still 1/3, right? But with point slope, I mean, I literally could write that dozens of different ways because the line's gonna have dozens of different points on it, right? Infinite points on it. So as long as I know the slope at any point on the line, I can write that equation. Now, what if I wanted to change it to slope-intercept form? Which one is gonna get the right slope-intercept form?
Both.
Either one is gonna get the same slope-intercept form. So if I distribute, I'm writing in blue right now, so if I do this, y minus 1 equals 1/3 x plus 4/3, right? Now add 1. So that would be y equals 1/3 x, and the 4/3, that's 1 and 1/3, so this would be 2 and 1/3. Everybody agree? Okay, what if I change the red one? What do you think that's gonna come out to?
Same thing.
It should come out to 1/3 x plus 2 and 1/3. Let's see if it does. So we would do, so now I'm gonna do this one up here. So this is y minus 3 equals 1/3 x minus 2/3. Okay, add 3. So y equals 1/3 x, and then 3 minus 2/3 would be 2 and 1/3. 2 and 1/3, okay? So they come out to the same thing, and it wouldn't matter. We could choose a billion different points that are on this line and write the point slope formula for all of those points, and they would all solve out to the same slope intercept form, okay? It's kind of the point. It's kind of the thing we want to happen. If it doesn't happen that way, then we broke math, and that's a bad thing. All right, so we're not going to do that on every slide now. That where we do all those examples. We'll just work this through. Write the equation in point slope form for the line that passes through these 2 points. So the first thing I need to do is find the slope. 3 plus 1 over -3 minus 2. So that would be 4 over -5, right? So -4/5 is my slope. Y minus 3 equals -4/5 x plus.
No,
Negative
it's
5. Negative. It's
It's
4
a-
and
it's-
you said y take away
y1 take away y2, right?
Okay, let's hold on let me answer one question at a time. So y minus 3, this is my point slope equation now. So y minus y1, and then x plus, or x minus x1, so x plus 3. So I've got the y and the x in the right place. Now let's talk about slope. You guys got to think about your math skills a little bit, okay?
Negative
4 over negative 5, you have a positive over a negative. What does that mean? You have a negative 4/5, okay? So if I wrote it as negative 4 over positive 5, what does that mean? Negative and a positive is the same thing. It's a negative 4/5. Okay, it's the quantity 4/5 that's negative. It's not one of the two numbers that's negative. 4/5 is negative. Okay, so it really doesn't matter where that negative sign lines itself up. It's as long as it's just one of them in front of that number. Okay, so I didn't mean to confuse there, but we need to think about that. All right.
Mr. Fish, so if both numbers were to be negative, then would the fraction overall be positive?
Yeah, I mean, if we did this, like if this was negative, so yeah, I mean, I'm over here off to the side, but if you had negative 3 plus 1 over negative 7 plus 4, that would equal, negative 2 over negative 3, which is positive 2/3. Right, negative over a negative, because this is just division. It's negative 2 divided by negative 3. Okay, so, yeah. All right. Write an equation of the line in point slope form that passes through the given points. All right, so just more practice. Slope first. M equals 6 minus 2 over 1 minus 4. So that's 4 over negative 3, which is negative 4/3, right? Did I get that right?
Yeah.
Okay. And then it doesn't matter which point you use. So y minus 2 equals negative 4/3 times x minus 4. So here the slope is going to be negative 4 minus 8 over 7 plus 2. Negative 4 minus 8 is negative 12. 7 plus 2 is 9, so that is negative 4 over 3. Ooh. That looks familiar.
Very.
Negative 4 over 3, same slope as the last one. So y equals, not y equals.
Y minus 8.
Thank you. Y minus 8 equals negative 4/3 x plus 2. So what kind of lines did we discover there if they've got the same slope at different points?
They're like parallel.
Parallel lines. We found parallel lines. You know they're parallel because they have the same slope. Parallel lines have the same slope. All right. Okay. Sketch the graph of this equation. Y minus 3 equals negative 2/3 times x plus 1. What can you tell me about the line that's going to end up on the graph if we have an equation written in this form? What do I know that's going to help me graph it?
You know where it goes on the y and the x.
I know an x and a y point. I know an ordered pair, right? Because remember our formula, y minus y1 equals m times x minus x1. So I know these two form an ordered pair. So what's my x value of the ordered pair? -1. Thank you for making it negative. And what's my y value?
3.
+3. Okay, so I know that my line has to go through -1, +3. All right, has to go through that point. Now what?
where it's y equals,
Don't need to do that.
Now you go down to right 3.
I know the slope. I can just count the slope from this point. So down 2, 1, 2, right 3, 1, 2, 3. So my line has to go through that spot. Down 2, right 1, 2, 3. That's a negative 2/3 slope. And then I just have to choose my straight line tool and go like that.
wherever our
Where is your straight line tool? Ha ha ha. All right. So we can graph a line straight from point slope form. We don't have to change it into slope intercept. In fact, changing it into slope intercept doesn't really help us, because then I have to have this right here is going to be like 3 and or 1, 2, 2 1/3 or something like that is my y-intercept.
It's 3 2/3.
No, it's 2 and 1.
Should be 2 1/3 is where the slope, the y-intercept would be. So that's harder to graph than putting them right in the vertexes of the graph. All right, let's do another one. So what is my ordered pair?
-2 and
X value is going to be
3,
+3, and Y value -2. Okay, so +3, 1, 2, 3, down 2 right there. And then what is the slope?
Up 1 over, or
Up.
1 over 2.
Up 1, right 2, down 1, left 2, down 1, left 2, okay? And then go like yonder, there we go. There it is. That's the line that goes with that point slope equation. All right, how about this? Write an equation in point slope form for the line on the graph. Again, it's handy because the y-intercept is going to be kind of hard to figure out on this one without doing some other work first. But I can find one point and I can find the slope really, really easy, right? So give me an ordered pair.
2, 5.
There's an ordered pair. And give me a slope.
2 over 1.
Right 1 over 3. 1 over
3, 1 over 3.
So, yeah, the slope is, I counted 2 over 6, which then simplifies to 1 over 3, right? Okay, so my point slope equation would just be y minus 5 equals 1/3 x minus 2.
Yes, I got it.
Okay? All right. That's it. I'll push you an assignment online. I haven't put it in there yet, but I will do that right now.